Okay, guys. So the, yesterday we kind of started off okay. Then I kind of lost the plot of things a little bit. So what I'm trying to do today is try to be a little bit more organized about it. So um, where are we at? Import is pretty much done from what we wanted to do. The only tweak I did it when I was playing with it last night was the follows was down here. Remember this code we had down here, which was something like this. I had PARTS equal to 20, and I had something like this going.
Yeah.
Where I printed out
Yes.
my number of parts. Now it's going to give me an error here because I haven't run out the cells above. All I decided to do was that so we're going to come back to this in a second. But what I decided to do was rather than just actually producing 20 parts, and remember we have a break here, so it only produces the first of the 20 parts. I basically put it in a loop and then had parts going 20, 10, 5, 2, and 1. And so what that was is the first time that loop ran, it produced the first file. Actually, I'll just do this all the way down because it won't take that long. When it's doing it, I can talk about it. So all this is the same stuff we had before, blah, 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 blah. And here's me outputting this stuff. So what this is going to do is I've now got a loop for parts. So it's going to take my data set, break it up into 20 bits, and save the very first of those 20 bits. Then because of the break I have here, it won't save any more of them. Then it'll break up my data set into 10 bits, into 5 bits, into 2 bits, into 1 bit. Which obviously breaking it up into 1 bit means I get the entire data set. And the reason I'm going to use that is that I'm going to do, because I'm impatient, I'm going to do all my analysis on the 20, on the sample that's made out of the 20 of them. But every so often, I'm going to go up to bigger data sets just to make sure I'm not missing something. Because it could happen that I could take my data set and break it into such a small data set that I might not be seeing something. So that's the only change I've made to import. Okay.
That's all using the same sample seed. So
it's using the exact same sample seed the whole time because that's it done up there. Yeah. And
yes.
so it'll always be the same stuff. And yeah.
So the first 2 of the 20 will be the same as the first 1 of the 10. Yeah.
In fact, it's more than that. Oh yeah, so the first 2 files of the 20 would be exactly the same as the 10. That's exactly it.
Yeah.
Mm-hmm.
Okay. Yeah.
So you can see me building up there. It's going to make 20 data sets, each of 49,000 rows. I could actually, if you want, put in a 40 in there if you want as well. So then it'll be down around 25,000 rows. If you want to be if your machine isn't that fast at all.
Yeah.
Okay. So I had that. That's the only change I made to that file. So today, what I'm going to do is I'm going to be a bit more humble about how much I can do. So if I go slower, I hopefully will have less typing errors and we can actually get more done. That's basically the plan. All right. So we're now moving to our EDA. So this is what I was asking you guys to do for today. So what I'll do now is I will do what I was kind of asking you guys to do, and we'll see how you get on. Okay. So this is our EDA that we had from yesterday. This first cell is exactly the same as before, and just import stuff. This is my auto load, which brings in my library, mylib. So if I open up mylib as well, there you can see there's mylib. If I click and open it up, so you can see here, and that's my file, mylib, and you can see it has nothing in it at the moment. Okay. And so my plan, the way I would do things is every time I write a function that does something, I actually would stick it into mylib and use that as my library. So at the moment I'm bringing it in, it has nothing in it. The next thing I want to do is I want to bring in my data set. So I want to bring in the very first one of 20. So I'm taking the smallest data set I have at the moment, very first one of 20. And I'm bringing it in as type string. So I'll bring that in. And as you guys noticing, the reason I like my shape popping out, because then it tells me, hey, I should have 195 columns. I had 194. I've added another one, which is my target. Give me 195 columns. Okay, so that's all we did yesterday. We did that. The next cell here is what I've started doing is I've gone back after talking to you guys yesterday, and I've tried to write down some of the things I was saying And just in case they got missed amongst all the audio and the rubbish that's there. So what do I want to do? For every feature I have in my data set, I have things I want to do, isn't want, because you want to get it past this assignment. And there's things that you'd like to do. The want things are things you need, if you want to put it that way. What are the two things you want to do? For every feature you have, you want to make sure that feature is valid. Okay, what does valid mean in this context? Valid means in this case is that the data is something you'd know at the point you're supposed to know the stuff. So billing, for example, would not be a valid feature. And record ID wouldn't be a valid feature. So remember again what those features are. Is if I go back up one, if I do df.head, these are my columns. Record ID, for example, there, I can't use that because it's unique to each patient. So that has to go. So that's the idea. I want to know what features are valid. Do features need cleaning? For example, if they have missing values and if they have outliers, you do that. And the things I'd like to know is, are the features related to the target or not? We've spent a good bit of time in class talking about, hey, you should remove features that are not related to the target because it reduces your dimensionality and all this kind of stuff. And that's basically what the theory is always on about. You want to make your fewer features you have, the simpler your model it is and all that kind of stuff. In practice, what tends to happen though is there was watching a very nice video of the guys who do fast AI, and the guy, the main guy who does that, I can't think of his name again off the top of my head now. He was arguing that all that feature, all that dimensional reduction stuff, it keeps the theory people awake at night. But the practitioners who do with real data sets, they find that that dimensionality is not as big a problem as the theory suggests. Now, I haven't seen his evidence for it, but the reason I would put a lot of weight in what he's doing is the library that he has developed, Fast AI, is really freaking fantastic. So he certainly knows his stuff. So I put a bit of credence to it. So the comment I would be doing is that, yeah, I'd like to remove features if they're not related to my target. But if I don't, it just means my training is a little bit longer than it would be otherwise. And so I think that's why their like is supposed to need. Other things I want, do my features need transformations? I know you did a lot of that stuff last semester in terms of normalizing and stuff. That's basically, I'm putting that down there because having those, normalizing would basically mean it'll improve my score of my model. But it wouldn't make my model invalid not to normalize. So it's something I'd like to do. Okay, that's the background. Where we got to yesterday and what I was talking to you yesterday is that I now need to go through a data set that's large. It has lots of categorical features. So what do I want to do for each categorical feature? Well, there's numerical stuff I want to do, and there's graphical stuff I want to do. The numerical stuff is build up my frequency distribution, so I can see, what categories, how many categories are there, and if I have a feature that has too many categories, I need to cut them down. I want to see, are my categories balanced or not, and this kind of stuff. Are they missing values? All that kind of garbage. I can do a goodness of fit test to numerically test this stuff. And I've graphical ones, basically a count plot does the same thing as my feature distribution, but it's just basically I can see it. And the way I'd always do this, I always do numerical and graphical, for the simple reason being is that if I screw up one, I'm unlikely, even if I screw up both, I'm unlikely to screw them up in the same way. So if my numerical doesn't match my graphs, then I know something's wrong.
Kieran?
Yeah?
Are you going to go through the goodness of fit test stuff?
Yes, if you want.
Okay.
Do you want?
That would be great.
All right, so that's basically...
I know I had an issue. I don't know if anyone else did. If you want to chime in, more than welcome.
Yeah, so, but that's more than happy. In fact, that's the plan, basically. And so I know, so what I want to do then, so I want to do basically these four things. Okay, so, other than that then, so that's all I've done between when I saw you guys yesterday and today is I just added those two sort of cells of notes. And you can take them down afterwards when you look at the video afterwards if you want. This here is this cell here. I gave you that cell yesterday, and all I'm doing there is I'm taking the labels for one of my features, which is type of admission, and I just copied them out from my PDF, and this is how I'd actually build up something I could use from that PDF. I did it manually by copying and region and putting it in. And the only thing that's probably new to you guys here is this thing. P print stands for pretty print. And when you use it, what you do is, if I show you the difference between P print and print, that's the version of using print. And if I use P print, it just lays it out nicer, right? That's pretty much it. But I can see now I have a variable called type admissions, and I can see the codes I'm mapping across. Okay, and notice everything's a string. So type of admission is not 1 or 2. It's the numeral 1 in as a string. I put everything as a string because it'll bite me later on if I don't. Okay, so we now go to doing the 4 things I have up here, and which I started doing with you guys yesterday. So because I know I'm going to automate this, I don't want to have type of admission everywhere. I don't want to be doing things like this. If you see down below, I don't want to be saying DF type of admission value counts, because I want to replace this by something else. So what I do is I have my variable which stores my feature name, and I have a variable that stores my target. And so I'm going to use that everywhere now. So the very first thing is my distribution table, or my frequency counts, whatever you want to call it. So that's all I've done there. And the important thing I've done there is I want to make sure that drop NA is equal to false, because this column can have missing values. Okay, now I run it. So I run that, and I see I don't see any missing values. I know they're there. So what's happened? Well, what's happened is the sample that I picked up here, where the hell are you? Which is 1/20 of my data set, is just too small. If I go to bigger and bigger chunks of my data, I'll eventually find a missing value. So if I go back to my first sample of 5, when I divide it up into 5 parts, you'll find you'll get missing values. Okay, but you can do that afterwards. Just verify everything what I'm doing is right. So I left it at 20 in a moment, and there's my my observations. Okay, so next thing I want to do, as I said, the type of plot that I gave you guys that I like is where I have 2 plots side by side. I have a plot here, which gives me how often things occur, and gives me my distribution of my various categories. And over here, then what I have is for each category, I want to know the breakdown, the relationship with my target. And that plot, I started using that plot. I saw it in the Kaggle competition a couple of years ago. A guy who did really well, and it's a really nice plot. So what I'm going to do is, I can give you the code for it, but I want you to build it up, because it's good to see how you actually do it. So what do I want? First, I want so the two regions, as I talked about yesterday, is easy. That's just this line here. All it's doing is doing subplots and saying my 2 parts, saying the number of rows, which is 1, and the number of columns, which is 2. Then what I do is I create a data frame by using group by and using size. So I go back as far as this, using size. And if I run that, I wanted my plot to appear in this side, and the way I do that is I specify my axis. So you can see here I've specified my axis being axis 0, and if I axis 1, the plot goes into the second part. Oh, sorry, hold on a second. I got a message on Slack, somebody asking what time we're starting. I say 5 minutes ago. What time meeting today? Sorry.
Rip Jonty.
Just started. Boom.
Oh, fuck, where's it gone?
Excellent. Thanks, Kevin. Alrighty. So we've got our plot there. You all happy enough for that?
Yep.
Is that okay? Yep, Grant. Perfect.
Yep, that's fine.
Yeah, sorry, Grant. Okay, now I want to get the other plot over here. Now, what's the plot I want? I want basically, so you can see, as an aside, Up there, I did value counts. If I look at this count plot, okay, you can see that that here is pretty much the same thing as what I have up there. So value counts and group by size will give me the same thing. Now I want to do another thing. So I want to look at now at my PD, and I want to do crosstab, if I spell it right. And I want to pass in there my feature. And I also want to pass in my target. And so I run that and I get this. Now, what I want to have is I want to have these guys normalized. But I want to do two things. I want to have these values here all scaled so the sum of them is equal to 1. But I also want to have the rows sorted. So if I go back to this table up here, the graph I have up there, if you look at the graph, notice the most common category is 1, then it's 3, then it's 2, then it's 4. I'd like to have this graph sorted based on how the most important categories. So what I'm going to do is this: go back up to where I have size, and I'm just going to sort values in there. And now when I look at my plot, I see that the things are sorted based on the most frequent categories are appearing on top. Do you all see that? Yeah.
Yes.
Yeah.
Grant?
Yeah.
Okay. Yeah, I stopped pausing and asking to see. Okay. So what I want to do now is this. I want to look at my crosstabs. So I want to know. So first, I want to build a chart on this. So I want to build a chart down here, and then after I build that chart, I'm going to actually put it up into my graph. So this is my. So I want to call this here DF, and let's call it feature target count plot. Are you putting something on the cooker over James or something? So here I've actually created my
No, it's not me. I don't
my
know
data
who
frame.
it is.
I'm only messing. You're my go-to guy to complain about. So I've created a data frame, and here I'm showing it. Now what I'm going to do is I'm just going to put in a few blank cells in between. So what I'm going to do now is I want to start editing, tweaking this. Okay, so this is what I have. What I want is I want to have that it's row totals. So what I want to do is I want to normalize it. Normalize, if I spell it. Normalize by rows means I say normalize index. And then if I get rid of that, actually don't need that one. And then if I look at that now, I can see that it's now normalized. Okay. The only thing, what's wrong with that now is this, is that I actually wanted these rows 1, 2, 3, 4, 5, 9, and dash to be sorted in the same order as up here, 1, 3, 2, so on like that. So I can't sort them now based on that because the totals are gone. All right. So what do I need to do is I effectively need to put my totals in. I could get rid of that. Go back to this and put in margins equal to true.
I think everyone's sort of being sensible about it, like, you know.
I could put in margins equal to true.
Hello? Hey, Buzz. Yeah. Oh, wait, no, you're in the middle of something there.
Yeah.
Okay. I
Sorry.
was just going to say hello to Grandad, but he's in the middle of his project there.
All right. I think we have too much noise. Okay, okay. So
Oh, sorry, you're in the middle.
Okay.
In the middle of a live lesson.
Okay, so where are we at? If I put margins in, I get my totals at the side. But then I won't be able to do, if I do normal, if I say, well, okay, I'll try to do that and normalize at the same time. And what it'll do then is, it actually gets rid of the total to the side because the total to the side don't make any sense because I've scaled it to be 1. That's what normalizing does. So since I want the scaling, I have to actually put in the margins in myself. So this is what I do. I just there's my normalize being done. Where am I going to get my totals from? Well, I get my totals from where are you? the data frame I had earlier on. So if I just do that as follows, I just do this total equal to this. Now again, run it here, you can see it. So after doing that, I now got my totals. Okay, and next thing I do is say, and next thing I want to do from that is I want to take my data, my count plot. I want to sort by values, and the value I want to sort is by total, and I want to sort in place. So there is me running that, and there you can see there's my output version. Okay, and see the way I've done it. I'm modifying my data frame up here, and in the next cell, then I'm always just printing out what my data frame is. Okay, so that's how I can sort of test to make sure I'm doing what I want to do is right. Okay, so that's fine, except now I've got a column here I don't want anymore. So let's get rid of that column. After I've used it, I discard it. Drop columns, and the column I want to drop is just total. And I say in place equal to true. Bloody hell, sorry. In place equal to true, and I do it all in a single cell to make sure I'm not getting conflicts and stuff. And now I'll show it again, and now I've got exactly what I want. This is now a data frame where I have all my actual categories sorted by how frequent they are. So I can put this thing beside this. And for each category along that row, I have how many are in the long, medium, and short. Now we could actually reorder the columns if you want, but I wouldn't worry about that. So I'll leave that. So we've now got this thing. So that's the code we put all together. So I'm going to copy that, go up here, and stick it into my plot up here. So this, if I put it, and then let's add in comments. First plot. Sorry, left. I just do left. Left plot. FREQ of each CATEGORY. Left plot frequency of each category, and right plot I'm going to have down here. RIGHT plot and breakdown. TARGET target breakdown. DOWN and within each category. You see, you happy enough with that? And now I need to actually plot the bloody thing. So where's my plot command? I'll just copy that down. There is my plot command. I want a bar plot again. There's my bar plot, and I want the horizontal bars. And this time I want it in the second graph, so it's axis 1. I run that and see what happens. I have over here, I have my plot on the left is as we want it. The plot on the right has my categories now in the same order. Look, 1, 3, 2, 4. So it has them in the same order. That's great. Except my bars are not stacked. They're just one beside each other. I know some people prefer it like stacked. I can never read them. Sorry, like in group like that. I prefer stacked. So STACKED equal to true. Run that again, and now I have it stacked. And to my mind, this is much clearer. I can, if I look at it on the, especially when I have three categories like this, 3 classes, I can clearly see here. And if I look at the green guys, which are the short-term patients, you can clearly see that hey, some categories are really good in terms of short-term patients. Category number 4, and who's got the virus? So category 4 is really good, I think, which is newborn patients. I think newborn, yeah, number 4. So thankfully they're not in hospital that long, and so on and so forth. So I now, only other thing I want to do is sort of relabel stuff and just give labels to these guys. And so let me just label stuff. So I'm just going to be lazy, and labels I put in earlier are so pimp dots and 2 labels. I want the x-axis set, and so let me just see what that looks like now when I label that. So I can have now count plot of type of admission, I have breakdown of target, and I have a column on top saying what it is. Okay, are you all happy with that plot? Or has anybody not got that plot? I suppose the bench should be on video. You can always come back and look at the code from it if you know. So we build it up
Mine
now.
looks like that.
Yeah.
It looks
Okay,
good.
so what we can do is at the end of the recording, I can stop, and if anybody hasn't got things like that right, we can do it. Now, that's my plotting bit done. Previously, I did my distribution. So let me now go across to my mylib file, okay, and create a function that does this stuff. Those two kind of things look okay now. So let me put them in over here, so just so they're out of the way. Okay, so I had a function there. I didn't find it yesterday, but I deleted. I don't know. EDA CATEGORICL. I presume that's how you spell categorical. There's my data frame I'm passing into it. There's my feature. And there's my TARGET, so my target. They're the three things at the very least I need to pass in. So let's now copy this stuff I have here into that function. And then I'm going to call that function and see does it work. All right. Okay, so the two things I was, the first step I was doing is my distribution table. So put that in. So I'm going to call it. Step one is my distribution table. You're now done. Okay. That's that guy. The next thing I have then is, this is my drawing my graph. Copy that. Go back in here. Step two, count plots, because the two things are count plots. Okay, and put that in there. And I need to just fix my indenting. Pop these out and indent in. So step one is my distribution table. Step two is my count plots, blah, 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 blah. And step three is the goodness of it that James was asking for in a second. So, but I'll save that for a moment and I'll see, make sure that this works. So I'll go back into my table. I can get rid of this cell now. I no longer need it. I can get rid of the entire cell, actually. X. I can get rid of my graphs here. I no longer need it. And I can get rid of this stuff. I no longer need it. Get rid of this stuff. I no longer need it. Because in theory now, I should be able to do my lib and whatever I call the freaking thing. I call it EDA categorical. I should be able to pass into my data frame. I should be able to specify my feature name, which is that. And I should be able to specify TARGET. And this should do my stuff I wanted to do. All right. And okay, it didn't print out my distribution. It did my plots. So let's go back into my code. The reason why I didn't do my distribution is because I forgot to put a display around this thing. And I did that yesterday as well. And like a goldfish. I had to do it the second time today. Okay, so run that now. And I have my distribution. Now, what I tend to do, if you use the table of contents over here, it'd be nice if I actually produced a label so it appears in my table of contents. So that's easy to do. All I do is go back into my code over here. And what I do here is just do, and I just put in, make it a heading, 1, 2, 3 heading, or 4 heading. Let me look at my levels. That's 4. So I make it 11 heading and just put in here, FEATURE.
Kieran?
Yeah.
Down on line 46 there, is that meant to be subtitle or is subtitle what it is?
It's sub, it stands for super. Not so.
Okay. No. Okay.
Well spotted. Because I originally thought that was subtitled the first time I saw it. Okay.
Okay.
And I said, but when you look at it, what does it do? It actually draws the title on top of all the other titles, so it actually stands for super title.
Perfect.
So I use that if I have a title in multiple graphs. And so all I've done now is I've now got a new a label. So if I save that. And now when I do EDA of a feature, I'll actually should have, I now got it over here in my table of contents. Okay. So I can actually, I can build up the whole lot of these guys all the way down as I do each, and each one will be just a single line. Now, where am I at in terms of my goodness of fit? Right now, we calculated earlier, and I should have done this for get this back. If I take this line back out, earlier we did cross tabs with normalization. Now I'm doing it without the normalization. So this is our cross tabs again. Okay. So this is my cross tab. This gives me my two variables, feature and my target. And it tells me how many observations I have in each combination of long, medium, and short with my various levels. I want to see, are those things, are the two variables target and type of admission related or not? And the test I need to do for doing that is called is called a chi-squared goodness of fit test. And the idea will be is this, the theory will be is this: those numbers I see in here, they're my values. They're my observed values that I see. What should I see if my two variables, target and type of emissions, were not related? Well, if they were not related to each other, then what should happen is that the pattern I should have in here should be independent of my various levels. And so what happens is there's an expected value I should appear in here. And the expected value comes from a nice easy formula. It's basically your row total along here times your column total divided by your overall total. That's the value you'd have in here if there was no relationship between my two variables. There's so you can calculate those expected values. You compare those expected values with your observed values, and the distribution they come from is called a chi-squared goodness of fit test. And you check your variable, check whatever it is, and if the difference is too big, then say, hey, this couldn't happen by chance. These variables are related. You can build up the steps you want for yourself, but you don't need to. There is a function already there to do this for you. So I just be lazy and use that function. So what is the function? First, I bring in the library stats. Okay, and this is the way I tend to bring in the library stats. I know some people use SNS for the abbreviation of stats, and I can't. So they might do it like this. It doesn't make any sense to me. Even STS, you could use it if you want, but stats is relatively. So I just prefer to use stats. So bloody hell. So there's my library stats. And in order to do my goodness of fit, well, the function chi-squared contingency has already all the work for me. So all I need to do is just call it. So if I do chi-squared contingency, if I pass into my count plot I have up here, it'll run, and this gives me back my data. This gives me back everything I want. So what is all this rubbish here? Let's do it in reverse order. This gives me back four things. The fourth thing it gives me back are my expected values I have within each cell in here. All right, that's fine. We won't need to use that at all. The next number it gives me back is my degrees of freedom. How to calculate my degrees of freedom? My degrees of freedom are the number of columns minus 1. So in this case, it'll be 3 minus 1 can be 2. And the number of rows, 1, 2, 3, 4, 5, 6, 7 minus 1 can be 6. So it'll be 2 times 6 to give me 12. So that's my degrees of freedom. So if you're manually looking up the probability table, you'd use that. And the number above that is the probability. So actually, I'll go back to the first one. The first number on top is the computed chi-squared statistic. That's the number you must look up your table and say, hey, what's the chance of this number occurring by pure fluke? And this number, the second number here, is my probability. It says, hey, the chance of getting 3,373 when I use 12 degrees of freedom is pretty much 0. So that would tell me that those two variables are linked. And now we tend not to just output all this rubbish like this, or I tend not to. I tend to just save that as a result. All right. And now I just want to output the bits and results. So the thing I tend to do is something like this. Is I output the following. Sorry. result. So what I've done there is this, is I've just taken the first 3 entries from my result list that I just saved. The first 3, the first one is the chi-square statistic. The second one is the probability. And the third one is degree of freedom. And actually I might put in 4 here. So notice my convention here, 4G is basically G is like F. So if I put F in there in both those guys, G is like F in that it outputs, it's used for opening floating point numbers. But what G does is G doesn't put the digits after decimal point if they're all 0. So you can see there when I do G here for this, my zeros disappear. It's probably a bad idea to do that, so I leave it as F. So you can forget about the fact that G exists. So what do I get? I get now, hey, I shouldn't actually use F. I should use E because I want to get it in exponential notation and see how low it is. But the idea is that's only small rubbish. I mean, once the number is small enough, we don't care. Yeah, sorry, James.
So that chi2 contingency will always take because the documentation said it takes an observation, and I couldn't figure out what an observation was.
Wait.
So it'll always take a crosstab essentially, like, of data.
Yeah, chi-square can be used for a whole lot of other stuff. Okay, but
Yep.
This will always take a crosstab for us.
Okay.
We nearly
Okay.
always use it. So nearly always for us it'll be two-dimensional table. It also works on a one-dimensional table. In that case, then what you do is you give a distribution going with it. But for us, this is the use case that we will use 99% of the time. So it's the one to worry about. It'll always take a crosstab. And if you look at if you do Python pandas or Python SciPy and stats goodness of fit, you'll often see entries where people actually build up the observations themselves or build up the expected, do a lot of code beforehand to calculate the expected. Point is, this function will do it all for you.
Yes.
So
okay.
rather than you actually calculate the expected and then going off and look up the tables or using a function to get the value from tables, I just do it all in one go. So this is nice and simple and just fast. Okay.
Yep, perfect.
All right. Now that's fine. That's that bit done. I need to put that into my library that I'm building up. All right. So I'm going up to the very, very top. And at the very, very top, I'm putting in my various functions, and I'll put these in some sort of logical order. All right. So I have my stats in there now. The next thing is I take all the rest of my rubbish that I have here, and I go back into my library, and there's step 2. Now this is step 4. Sorry, I can't count. Step 4, and GODNE of fit. And so there I'm calculating my result again as before. I'm just making sure everything is fine. And I need to put back in my function. So if I look at, I need to recompute this. That's the important bit. See the way I'm doing? I need to recompute it. Why? Because I don't want normalized. If I normalize stuff, then that's going to change my stats. So I need to have it non-normalized. And there's my, so there have I built up my crosstabs. Here I'm doing my goodness of fit computation on it. And here I'm opening my result. So I've now got 4 things. I've now got my features outputted, my count plots, and I can count step 1, step 2. Yeah, this is step 3, sorry. Okay, I'm doing 2 plots in here in one. So I've got that function now written. So now let's go back to my EDA, and I should be able to take a single feature like type of admission, run that, and I see there's my distribution. I don't have any missing values there, but as I said, they can appear. This here is my plots, and this is my corresponding output of my goodness of fit. I probably could tidy this up a bit. Let's just pimp up my outputs a bit. There's my distributions, blah, 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 blah. COUNT, PLOTS. There's my count plots. And then down here, I can do my pi S squared and GODNE goodness of fit. And there's that, and you just print it out. Actually, yeah, just print out and display. So I've just tweaked it slightly, and if I run it again and see what it looks like, I've now got my distribution, my count plots, my chi-squared goodness of fit test. All right. So what I've got now is something that I can use for multiple variables. So if I get rid of the stuff that's been down here, X, and get rid of that stuff, I can now take that command and I can now apply it to other features. Another feature there, there's a, forgotten my name of features, discharge. Was it discharge? I've forgotten. Sorry, one second. df.columns. My columns are discharge. So I can, I mean, obviously you guys are fortunate in computing, you know, the whole bunch of having a function. I now have a function, so I can now use it on other features. So now using this, I get my breakdown on my categories, and I can see for discharge, I can see that, hey, it's very, very even, except there's some weird ones, weird legacy patients from the previous quarter. I can see my breakdown in terms of my plot. Okay, that's fine. Excuse me, and I can see my goodness of fit. So I talked about this in class at last Wednesday, that when I looked at the plots first, I said, oh, look, those categories are all pretty damn close to each other. Surely there's no relationship really between my discharge and my target. From the graph, there doesn't appear to be, but from the goodness of fit, it is. Now, it is not practically zero as it was in the previous variable, but it is small and it is significant. So we should be including it. So I've now got a function I can use. Now let me try. So let's go look. So let's put my features in order. So this is the first feature I have up there. Escape A. So the first feature I looked at was discharge. I can get rid of this stuff now. I don't need it anymore. There's my first feature, discharge. And two things out. So then I need to pass, after I do that, I need to escape A, markdown. I need to put in comments. So what comments would I need to make? What observations, and this is where you guys come in, what observations do you guys need to do or need to make based on that feature, so it allow you to decide how you're going to use it. So that's the part you need to work with. The suggestion I'd have is this: these patients here, the patients that are in the previous year, they're legacy patients. I would be tempted to get rid of them, and just drop those rows. It means I won't be able to do predictions on them if those appear in the grading data set, but there won't be that many of them. So I'd be tempted to just drop them. And that's what I would probably think of doing. Or you could think of actually combining with the previous one. Yeah, sorry, John.
Yeah, just wondering, discharge you only know once they've left. I thought we were meant to use predictors that we know up until they're admitted.
Sorry, can you say that again? I was very low.
Yeah, sorry.
There you go. How's that?
Perfect. Yeah,
okay.
Sorry.
Yeah, so I thought we were only meant to use predictors that we were aware of prior to them being admitted on the first day, whereas discharge is something you know at the very end, right?
Oh, actually, you're right. Yes, completely right. Of course, I only know discharge at the very end. Completely right. Yes. I'm sorry. Yeah, absolutely. So don't touch discharge at all. Yeah. So that's a no-no. Sorry. Thanks very much. Thankfully, I can cut that out of the video. Yeah, you're completely right. That should entirely gone. All right. So we get rid of that. So the first of my features that I can deal with, as far as I can see, is as admission, and it's really bad because I've gone to the very end with discharge, and never once thought of the fact that I don't know that till they leave. That's very bad. Okay. Thanks, John. So discharge, CO columns. So let's look at my rest of my columns. Actually, I should have the actual PDF open. Let me open it up. So I will send PDF. Where are you? 004 doc. So okay. So we got as far as yeah. I mean, yeah. The discharge no good to me. Discharge no good. The next one along the line. Well, if you want to be brave, you could put the next feature into this thing, into the function we've just written. But if you do, it'll crash. And the reason why it'll hang. I mean, just run it to see what happens. One, I get this table here, which is way too long to be of use. Okay, and now it's stuck waiting to do my plots. So I'm going to stop it. So one thing that's wrong with the function that we've created here is that it's not at all robust. It's not because it means we're only just developing it. So one of the things I will be doing is I would only be displaying certain stuff if the data is appropriate. So one of the things I might do is I go back to my function I have over here, and I would probably put some sort of comment like this: if df FVATURE, if df feature dot number, if the number of unique values was bigger than some max categories, then I'll open a message and just do nothing. So I might do something like this. So if the number of different values or categories my feature has is bigger than some value, I just open a message and I stop. Okay. What's max features? Well, you can pick whatever you want. So the way I tend to do I might do something like this. I might create an optional parameter in my function, EDA categorical, and now what that's going to do is it's going to have a limit of 20. See what you want. So if I run that now on, so go back to my so that's inside my function. All I'm doing, if the feature I'm looking at has too many categories, open a message and just leave. Okay. So if I go back now and use that, there's my first feature I've used is type of admission. That runs fine. The second one is discharge, and that's, I mean, now we're running now that discharge, sorry, that ID, and sorry, go back to my function. I've got data being used someplace. There's data, df. And now run that again. And all I get is a message opening up to too many features. And so what you need to do is you need to combine these guys together. So now how are you going to combine these guys together? That's harder work, and we leave it for another day. How would I do it? Well, if you go back to your data that we generated, I gave you, there's 4 files there called faculty type. And the way I would be doing it is I would be taking the 560, sorry, just get I have to get something. Sorry, I have 556 categories. Those they're all, each 556 are my individual hospitals. The way I'd be doing it is some of the hospitals are really small, so I mean I could just clump them all together. But the way I would be thinking about it, I haven't done it, is I would be looking at my faculty type, and based on my faculty type, the faculty type has a number of columns based on I can't remember what phrase, whether it's emergency place or non, this kind of crack. And what I would do is I actually would group my hospitals based on faculty type. That's the way I would do it. I gave you the 4 ones for each quarter because some hospitals change their faculty type between the various quarters. And I would probably just pick one of them and just leave it at that. But that's something we can talk about later on. So for the moment, what I'm going to do is I'm just going to ignore that column. All right. This is so the provider name. It's the same thing. That basically gives me the same information as my ID. My type of admission, I can use that. So I'll go and put that in. So I can use that. My type of admission. Actually, I'll just bring this thing down just to remind me. That's that guy. So I'm skipping over that. My type of admission, not type of admission. I did type of admission. I'm a goldfish. Source of admission. So I should do this, and I should be doing these in the order that they're in the. So I'm doing the columns in the order they're in the notebook. So TID, I'm skipping over. Type of admission, I've now done. Source admission, I get this. And so what I've got again, source admission is significant. And you can see from the plot as well. So what I wanted, what should I be doing? I should be looking at this and saying, okay, there are a number of categories here I should be joining up together because they're all too rare. And start doing some of that. So, and I keep doing that for all my features all the way down. And also I go back up here, I notice I have some missing values. So, yeah, sorry, James.
So should we just put all those list of names in a loop and just have it print out all of them?
You could, okay, and that's what I do for some of the stuff I do, okay. I just put it in a loop and it builds up all that stuff, and then I look down through all my plots.
Yeah.
The reason I didn't suggest it to you guys is what would be is that I wanted to you want to make sure you actually look at those plots and think about them and comment on them. Okay.
Yeah.
Because otherwise you just, I mean, yeah, you're right. You could actually just simply it'd be just trivial to do for FN. And then I can just go, actually, what I could do the following for FN DF the columns. I mean, I could go really stupid and just do that. Do you see that there?
Yep.
I could, out of curiosity, if I just do that, what happens? I get, I mean, that's not a bad way of robustly testing, see if the function actually works. All right.
Yeah.
So now I see all my columns all done, all the way down, blah blah, and it's going to take a long time to get to the bottom. So I could do that, and him just scan it. But the idea would be is that I don't want you guys to get overwhelmed with too much data.
For sure.
Right. So I've been tempted to go slowly and not do what I just done. And where am I getting stuck at? Why is it getting so long? It should be more than that. This is now, okay, stopped for some reason. Lynn passed, what did it pass there? You can see here. So again, this is one advantage of doing it this way is you can stress test that function we've written. We've got a feature here, a spec unit 4, for which all its values are missing values.
Oh wow! Okay.
So that means then the function, so the plotting won't work in that case. So you can use it to kill out functions if you want, but columns if you want, but I wouldn't bother. So I go back to this thing that I did there and I just undo it. But you could write it. So I would prefer to do the first column, get what you have here, look at my observations.
Right, now comment on it.
Just put in comment on it.
Okay.
COMENTS comments in here. Should include RELATE to TARG related target. Should include in model. If I spell should include in model correctly. It has rear RA, RE, CAT, EG, or IE has rare categories. Should IME or GE, okay, and has missing values, and the answer is yes, it does. Okay, we just can't see them in this data set. But we can go up and check later on that has missing values, and I should basically merge, and I'd be tempted to look at it if it has missing values. If I look back at my labels again, remember where are my labels for this thing? My labels were the dash was invalid, 9 was information not available. All right. So if I look down to my plot, I look at this and say, hey, 9 and dash, they're really small, and if I'm missing values, they're really small, and I might just combine all of them together. So that's basically, so they're the kind of notes, comments you kind of want. Do you get the idea? So that tells you what you need to be doing. So inside in your model, you should be doing this merging. Okay, and then the same idea happens for this guy. This, you've got 4 of them to be merged, 6, 8, whatever D is, and 9, and that things just merge them. That's all. Okay, so you can see the kind of process I want you to do for the EDA. We do that for our categorical variables. Our numerical variables, we want to draw a plot. You want to be start putting in, deciding what is the same missing value you want to put in for those guys. For missing values and categorical variables, if there's only a few, the rule of thumb I would be using is if there's a few, practically every categorical variable in this data set uses a dash for a value that's invalid. So I'll be merging my invalid column with my missing value column is the way I'd be doing it if the numbers are low. So those, for example, those 3 there, I certainly put them together is the way I'd be doing it because they're only small numbers. Okay, that's your EDA down. I was going to actually jump to the model bit next. I might, what time is it now? I might leave that till tomorrow. Is everybody happy with what I just did there? Or anybody have any questions on that? No, hello?
No, I'm good.
Grant, okay. Sorry. Yeah, perfect. I thought the moment was gone. Okay. So actually, well, let me see. What time is it? It's 7 minutes. Let's do the modeling bit as much as we can in 10 minutes. Okay, so just so you move on to that. So the modeling bit. What do I want? So go over to my file, create a new notebook. This new notebook I want to call O3 model. All right. So there's my model. I go up to top of my EDA and copy the first 3 cells. I copy the first 4 cells in. All right. And this is my model. So there's the first cell is the same as before. That's my seeding stuff. That's bringing in my library. This is bringing my sample. And again, should the same sort of numbers. And what do I want to do in this? I want to, so let's actually put in, what I do is I'll put in labels and markdown cells as the things I need to do. If I actually just look first at my data frame, and actually just look even at the first row of it, if you go to the very, very far right of it, where you have your target, you can see lots of missing cells, you need empty values you need to get rid of. I see my target is actually a string. I want to change that. So the very first thing I'm going to do here is escape M, is the steps I want to do here is convert or encode my target. Okay, so I do that before I do anything else. How do I want to encode my target? Now, so it's a string. I need to convert it to numbers. This is something I need to do for all my columns, all my features when I keep them. There's a number of ways of doing it. The way I'm going to do it, it's a little bit longer, but it allows me to do it's the most versatile. So let's actually just let's just do it. So very first thing I do is I bring in the label encoder. that I have from my pre-processing, and I create an instance of it. Let's call it label encoder target. So I'm going to keep this for all time. I'm going to use this to convert from numbers, from words, short, medium, and long, to numbers. But I always want to do it to convert back, because the person who gave you the assignment was being awkward, and he wants the predictions to be back in words, not in terms of numbers. All right, so you need to keep that label encoder. And how to do my transformation? Well, all I do then is I do this. I apply that by fit and train as normal to my data. And if I just see the first couple of bits of that, what I end up getting back is HAAD, is I end up getting back, sorry, I should just play it because it's an array. So it takes in my short, whatever it is, and gives me back an array of numbers. I save that to my data frame. So I do D data frame. I could do data frame.codes. So it keeps it separate from, there are my two separate columns. I could do this. I don't like doing that, because then what happens is I have two columns. So I tend to just prefer to keep it back into my target. But if I do this, before we do it, just look at what is the type of target. Type of target at the moment is object, because it contains strings, and in the version of Python that we're using, a version of pandas that we're using, it's going to keep it as object. So if I run this now up here and then do type, I can see it's now ints. Why am I going to use that? Well, if I go back to this cell and I try to run it a second time, it actually is doing something different now, because the label encoding is working on a different set of data. And so this is a cell I can't run more than once, because my label encoder now has wrong stuff in it. So what I should do instead, is I should do a test. So I can see here now that this thing is now of type int. And if I do equal to int, so I should be doing a test up here. I should only be running this thing if it is not of type int, because I'm updating a column that I currently have. So this is what I should be running. So I'll go back up to my code. I load that in again. All right. And here now, when I run this, it'll give me of type int to be true. And what I could do is, what happens? I want to use that encoder to go in reverse. So I put it here, and that it works in reverse, and then I'll stop. And just so you can see what happens, what I'm going to do is that's my original target. I'm going to transform it and call it target 1, and then I'm going to reverse transform target 1. Actually, I'm going to call it target 2. Reverse transform target 2 to give me target 3. All right. So this is here. If I run this, and what's wrong with you? Because I didn't save it. So target 2 is equal to this. So I need to run it twice. And so I get rid of that. So let me run that again. So here I'm going to do my encoding. I save my target 2 and then do target 3. And if I just see what happens there, df loc, and if I take all rows and take my corresponding targets. So I have target, which is my original column. I have target 2, which is the one I encoded, and target 3, which is the one I inverse encoded. So target 3 and target should be the same thing. So let's just look at the first couple of these guys. So I can see there, look, there's my original data. This is me encoding it, and this is me doing my inverse in transformation. And I need to do that because I take this data, I encode it, I use my models when I'm encoding it using that, and afterwards when I do my predictions, I need to do my inverse transformation. So now I can see that the whole process works. So let's just put that in, put that as a comment just for a moment, just so you can have it there, and I'm not using it. So I've now got my encoding of my target done. So brings in my data set, I encode my target, okay. And next thing I need to do in here, escape M, is I need to do my split, train split. I need to do a test train split, and the next thing after that, then I put in my extra stuff I'm going to do. That then I'll stop, let you guys go off and do something else, is I need to do my ENCOD encoding of CATEGORICLBARA features. Encoding of categorical features, escape M. The next thing I need to do there is filter. It's basically bring in my models and train them. So let's just do my test train fit. Escape A. So what are we doing there? Well, we're doing our usual thing that we bring in. I can either, there's my train test split function that we have. Same thing as before. And these are the code. I'm just copying and pasting from the notebook that we have used for the credit card. There's my target, and it's called target. My X is my data frame where I've dropped my target. My Y is just my target. And all I'm doing then is I'm creating 4 data frames here. X train, X test, Y train, Y test, where I'm taking my my data and splitting it up. And the test split there, I did 0.4, so quarter of it is into test. The actual number you pick here is not that big of a deal because we've loads and loads of data. So yeah, you can do 0.4, whatever you want. 0.4 is I'm leaving it with that 0.4. So that's built up 4 data frames I need to use, but those data frames have lots of columns I don't want. So I need to start filtering out those columns. So the way I would do it is this: is I would create a list called features, and at the moment, based on my EDA, and based on the input from John, the only feature I'm going to actually include right now is type of admissions. Originally, I had discharge. I'm embarrassed to say in there as well. So I have type of admissions. Okay, so that's my features. And what I'm going to do then is this: is I'm going to create a new data frame called DF model, which basically is just made up of those features. Okay. And what I'm going to do here is I'm just going to head just so I can see it. So there's my admissions. Now, this column here looks like it isn't what I want, but be careful, it's not. Those 3, 4, and 3s, they're not numbers, they're strings. So what I need to do is this is a categorical variable. Now you could just actually convert it to ints. That would work for type of admission, but it won't work for the extra, for the feature down below, source of admission, because I have some categories that are not numbers. They're D there, for example. So what you need to do is I need to encode this, okay, and before I can actually bring it into my model. Okay, so what I'll do is it's 17 minutes past 12, so I'll stop. You have other stuff to do. Actually, I'll answer James' question and then I'll stop. Yeah, James?
How did you know that was a string, Kieran?
Oh, how do I know the string? One, because I had put everything as strings, okay? But I always know it's a string because if I just do, if I do it on any data frame, do it in that dot type of admission, D type, it'll give me back a string. Always,
Okay, so
always an object. It'll always be. It's effectively a string.
So it's just because like we imported them as strings, you were like, oh, they're strings, like.
Yes, you
Okay.
might say, hey, well, if I didn't import it as strings, that'll be a number. And the problem with that is that even if we imported that column, if I go back all the way up to my very, very top where I did my import, and I can do it even in model. If I go back to my model where I import this as string here, even if you get rid of that, okay, it'll still be a string. And the reason why it'd still be a string is because if you look at your EDA, so when you get that warning, okay, but if you look at your EDA, what do we have? We find that we have a category that's made of a dash.
Yes.
So it's a character. So what it'll do is it when it gets to that first dash, before it got to that first dash, it was treating it as an integer. It got to that dash and then it said, okay, I can't treat it as an integer anymore. I now need to treat it as an object.
Okay.
So you're going to have to do that. That nearly happens for every single feature in your data set. And if it doesn't happen for a feature, then it doesn't happen by pure luck. So I don't like bringing in data sets that act differently based on pure luck. All right.
Yeah. Okay.
So that's
yeah,
why
yeah.
I just I'd be anal and just do the treat it as a string. So what I do is I now need to encode this. Okay. So what I'm going to do is I'm not going to give you an encoder because it's given the time. So instead, what I'm going to do is I'll just give you the import command you need to do. There's a number of ways of encoding. The one I would suggest you learn how to use is, and have this, try this for Wednesday, tomorrow, is bring in your, sorry, not that, I already brought in that binarizer, bring in, so I'm suggesting bring in the label binarizer, and I create an instance of it, and I train. I train based on my whatever my column is. So, if I have a number of features, I'm gonna have multiple features up here in a second. So what I do is, sorry, I didn't mean to do that. Later on I'm gonna have multiple features here. So what I do is I just go down here and just do FEATURE. If I spell it right, URE equal to FEATURES features. So, because you can see I'm going to be doing this in a loop later on. So what I'm going to do here is this. I bring in my label binarizer. I create an instance of it. I train it on my disk to actually run it. If I run that, something weird happens. And well, weird happens is because I forgot to put brackets. If I run that as this, I should get an error. And the reason I get an error, Jesus, I apologize. I'm trying that on this. If I run that, what I was going to say, if I run that, an error is going to occur, but as things work out, it doesn't. The error that I was expecting to occur here is this: is that this label, we've loaded in this thing as a string, but when you take a single column out of a data set, if it can convert from a string to an int, it does. So something you will have to do, you just didn't have to do it here, is that you actually have to put in here a second convert to string to make sure it actually treats everything as a string. It doesn't automatically convert it to integers. So that's what that bit here is doing. So if I do that here, what that has done is this. That has taken my single column, which is my features, which is my type of admission, and has now made up 1, 2, 3, 4, 5, 6 separate columns, representing my 6 separate categories that I had in here. 1, 2, 3, 4, 5, 6. You might notice, hey, there's 7 categories. Why didn't that make the 7th category? Because it didn't see it, is basically what happened. So there's my transformation being applied to those guys. All right, okay, what I'll do is, so what I'm gonna do now is this, what you're gonna do is this, is the column I have up here called feature type of admission, I'm now gonna replace it by those binary values, 0s and 1s. And then from there, I can actually go and apply my model or my classifiers and do it. So you have a shot at doing that because it's now well past 12, quarter past 12. And you do a shot at doing that, and I'll actually talk about it. I'll continue on from here on tomorrow, Wednesday. Okay.
Yeah.
Right.
So we're replacing those values.
You need to replace type of admission.
Yeah.
By basically these 4 columns, these 6 columns.
Okay.
Okay. So actually, what I'll do is I might put the code in just so you can see it. Is the way I've done it. Here I'm building up a name from each. So I have here columns, but I have no names with them. So here I'm doing is I'm building up names, and then I'm doing the following. For K name in names, and I want to build a new data frame. So let me just fix this. So so back up here, I've taken that feature type of admission. Here I'm creating a data frame that just contains admission. There you can see it there. Running this code, what it's doing is it's taking my data frame model and adding on extra columns for every different category it saw. It added an extra column. So if I run that, sorry, column is wrong. So it should be in feature. And I call it wrong, so it's LB. Oh, where's LB results? I've got to save it. I created an instance of my transformer, but I never saved it. So LB results is this guy, and run it now. See what's this thing now. So what that has done now is, see the way I have my column type of admission? I now have 1, 2, 3, 4, 5, 6. I have 6 new columns, and the name of them is the original name, and I have a prefix saying what is the actual corresponding value the category had. So _1, _2, _3, _4, _9 at the very end. And the last thing I do then is I drop my type of admission because I no longer need that. Can you get the idea? So what I've done there, if I do drop COLUMN, and I didn't finally show it. Okay, and columns. So right now, in this step here, encoding my categorical variables, I've just done it for type of admission. But you can see that this just, I can replace this thing by a loop running over all my features. And for all my features, what do? I do label encoding, binarizing. And for each value of my label, that's what I'm doing in here, for each category I have, I've created a new column in my data frame. And the name that column has is just got by my feature name with an underscore followed by the actual label value. So it's 1, 2, 3, and so on. And I do that. I copied that out there and put that into there. I do that for all my features. And if I do that, sorry, to permission, I thought I did it. So actually, because I've got rid of it. So run, you can see it, run that's it there. Now what I have at this point, I now have a data set I can use for my model. So from this step onwards, what you're doing is doing very much similar to what we did for the credit card. For basically, I take this, get the values out of it, VALUES, and actually if I just cut and paste that so you can have it. I take my values out of it. I convert those data frames to values. So you can see here, this is, I've done it for train, tests we haven't done. I did it for train, and now I can actually go and bring in my classifiers that we had from before. So from then on, all I'm doing is cutting and pasting the code from the credit card. If you bring that in, I should now be able to train this thing based on, so I'm cutting, pasting code at random now. And I should now be able to train this stuff from as you did for credit cards. So now I've got a training, so look, now I've got a training score of 45%. All right. So we've got, I've gone over time, but we've got now a basic training done. All right. And on a single, we've taken a single feature. I haven't cleaned it up. I just basically encoded it and used it. Now what you need to do now is start looking through your features and asking John ever so often, should I keep that feature included or not? And I include my features if they're valid, and I should be getting a better and better training. Okay. Now I haven't done anything of that. I haven't done anything of talk about different scores. I'll talk about that tomorrow. Okay, guys. Sorry, I'm very sorry I ran so long, and I'll try to be better in terms of time tomorrow. Are you all happy enough with that? Can I sign off, or is there any questions you want to ask before I go?
I'm good. Thanks.
Sounds good.
All right,
I'm good.
Grand. Okay. Okay, guys, and sorry, girls, I should say everybody, folks, I should be neutral. Sorry, that's about it, and I'll see you all tomorrow. Take care of yourselves, okay? Best of luck.
All right, thanks, Kieran.
Thanks,
Best of luck.
Kieran.
Bye.
Bye-bye.
Bye, thanks.